Hi again, everyone. Dr. Tom McNamara back here on the document camera talking about some applications of multiplication. And the first application I would like to talk about is finding areas. Okay, now, just to be clear, when I talk about the area of a figure, what I'm talking about is the number of 1 by 1 squares that it would take to cover a figure. So this square is 4 by 4, all right? But we can see here I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 1 by 1 squares covering this figure. So the area of this square is 4 times 4, 16. Okay, I don't have to count up the squares, I can multiply. And this would work the same for rectangles, for example. 1, 2, 3, 4, 6, 7. 2, 3. Let's say 7 by 3. 3 units high, 7 units wide. Okay, I could do the same thing and divide this up into unit squares. But I bet if I did that, I would get 21. I'll just go and do it for funsies. Okay, so if you want to go ahead and check my work, you can pause the video and count up these squares, or you can see I have 3 rows, and each row has 7 squares, 3 groups of 7, 3 times 7, 21. Or if you like to think of it, 7 groups of 3, but since multiplication is commutative, 7 groups of 3 would also be 21. Multiplication also comes into play when finding area of triangles. Let me see here. Let me do a 1, 2, 3 triangle that's 3 units high and 1, 2, 3, 4, 5, 6 units across. Okay, 3 units high, 6 units across. Okay. Now, the thing about triangles is every triangle is half a rectangle. And we have already talked about how to find the area of a 3 by 6 rectangle. It would be 3 times 6. And since this triangle is 1/2 of the area of a 3 by 6 rectangle, all we do is take the area of our 3 by 6 rectangle and cut it in half. 3 times 6 is 18. Cut 18 in half, and you get 9. Okay? So area comes into play in that situation as well. Okay, and let's talk about 1 or 2 applied problems here. Okay, so in this first problem, let's pretend we have an orange juicer, you know, one of those machines that'll take an orange and squeeze it and make me some orange juice. Okay, and let's pretend that it takes 13 oranges to fill 1 pitcher of juice. Okay, let's pretend I have a pitcher that I like to put my orange juice in. And it takes 13 oranges to fill this pitcher with orange juice. Okay, so let's pretend I'm having a bunch of people over. And we'll ask, how many oranges would we need to fill 6 pitchers. Okay, how many oranges would we need to fill 6 pitchers? Okay, well, each of the pitchers requires 13 oranges, so I could do the problem this way. I could do 13 for the first one, and 13 for the second one, and 13 for the third one, and 13 for the fourth one, and 13 for the fifth one, and finally 13 for the sixth one. And I could do all these additions. Or I could remember that multiplication is repeated addition. Multiplication is short for repeated addition. I could do 6 times 13. Okay, 6 times 13. And if you want to do the vertical method right here, 13 times 6. Okay, 6 times 3 is 18. Carry the 1. 6 times 1 is 6. So 78. Okay, so I would need 78 oranges if I wanted to do 6 pitchers of orange juice. Okay, so a example problem where multiplication came in handy because we had groups, 13 oranges for each pitcher, and we had 6 pitchers to fill up with orange juice. So we're doing this, which is equivalent to multiplication. Okay? Typically, when you see 13 for each, that indicates we're probably going to be doing a multiplication to actually solve the problem. Okay? So keep your eyes open for that in this exercise set.